For the current task, we will see how to establish an AM modulated signal in a generator with the objective of observe the signal in an oscilloscope and then compare the signal on a spectrum analyzer with a FM modulated signal.
At first, we will use the AM signal. For that case, we need to establish the carrier to 100 kHz sinusoid. Then we will put the modulating signal as an internal 10 kHz tone. And the depth modulating is going to be 50%. Of course, we establish the AM modulating system. Once we have put the parameter on the wave generator, we can observe the AM modulated signal at oscilloscope, changing some options like volts and time. Then we need to know which is the maximum amplitude value. For that, we select Measure button and then the tension option. With this, we can know the maximum amplitude value, which is 78 millivolts. The next step is observe the minimum amplitude value in the screen counting the squares. Knowing that 28 millivolts is the minimum value and the previous maximum value were 78 millivolts, we can use the formula to obtain the modulation index, which matches with the parameter established previously at wave generator. For the question, what happens with the signal when you reach a rate of 100% modulation or above? The answer is the minimum amplitude value disappears. If we want to observe the spectrum of the AM modulated signal in the spectrum analyzer, we will establish a carrier with 1 MHz and a modulating frequency of 20 kHz. Then we can see the sideband signals at spectrum analyzer. Once we have put the parameters on the wave generator, we have to put the same parameters on the spectrum analyzer. These parameters are 1 MHz in the center button and 20 kHz in span button. Then we can observe the sideband signal. In the case of FM signal, we have to put the FM modulating system, and the parameters are the same with the AM modulating system, but maintaining the frequency deviation of 50 kHz. If we make the comparison about the spectrum at the spectrum analyzer of AM signal and FM signal, we can see the differences in the sideband signals. We can see the FM signal has more sideband signals.